Welcome to the deep dive. Today, we're digging into something pretty unique, not just source code, but the actual cross-compilation toolchain behind this, well, highly unusual operating system. OFIA dollars, built for the old PowerPC 750, like in an iMac G3.
Right, and this toolchain, it's fascinating. They call it the engine of gnosis. Its whole job is basically translating these really intense philosophical ideas into code that runs on that pretty constrained G3 hardware.
Okay, so philosophy driving the compiler. What are these core ideas?
Well, there are three big ones: absolute sovereignty, eternal sovereign recursion, and this really strong focus on watt-byteware frugality.
Watt-byteware frugality. Sounds like energy and memory efficiency.
Exactly, and if the toolchain messes up any of these, the whole system kind of violates its own rules. It's that strict.
Let's start with frugality then. The sources point straight to muscle libic. Why muscle?
Muscle. Yeah, that choice is all about purity and minimalism. It has this incredibly low constant overhead, often under 8 kilobytes of global data size.
Wow, 8K.
Yeah. And on that G3, keeping resource use down is absolutely critical. They talk about avoiding a metabolic shift, basically turning into a power hog.
Okay, makes sense. But then the toolchain forces static linking using dstatic. Doesn't that usually make the final programs bigger? Seems a bit contradictory.
It does seem that way at first glance, yeah. But here's where the philosophy kind of overrides pure, simple byte counting. Static linking gets rid of what they call egomality.
Egomal.
Yeah, it's their term for the sort of corruption or unpredictability that comes from one-time dynamic linking. External dependencies, linker chaos.
I see. So they trade some storage space for predictability, deterministic integrity.
Precisely, and it actually helps speed up something called the rite of digital purgation.
Right, I saw that. That's about zeroing out the .bs section, the uninitialized data.
Exactly, to wipe out any ghost bits or original SYN artifacts left over from open firmware when the system boots.
So cleaner startup.
A faster, cleaner startup. The toolchain uses flags like Oak says for size optimization and function sections to keep that BS area small. Smaller BS means that assembly loop, the clear loop, finishes faster. Quick purgation.
Okay, so there's this intense focus on efficiency, but then they seem to throw it away in one area, this purity over frugality idea. They actively reject the PowerPC's floating point unit, the FPU.
Ah, yes. That's probably the most striking mandate. It seems counterintuitive performance-wise.
Totally. You're ditching the hardware designed for fast math. Why?
Numerical purity. That's the driver. The issue is the standard, i.e. 754 floating point. It requires truncating irrational numbers like their sacred constant full, the golden ratio. To OFIA dollars, that truncation is numerical heresy, compromising truth for speed.
So the toolchains have to step in and block the FPU.
It has to enforce M soft float. All that math gets forced onto the PowerPC 750's integer unit, which is, much slower for this kind of calculation.
And it gets worse, right? I saw mentions of 64-bit fixed point math.
Oh, yeah. Functions like energy-aware cleave, they mandate 64-bit fixed point, which means you're generating these massive 128-bit intermediate results during calculations, computationally very expensive on that hardware.
Wow. So speed takes a backseat to maintaining the exactness of 48.
That's the purity over frugality mandate in action. The philosophical credit outweighs the speed penalty in their view.
Okay, let's shift to the engine of gnosis part. The system gets stuck. Prophetic delay.
Right. Because the sovereign paradox, they ideologically reject external knowledge, meaning they don't want to rely on documentation for Apple's proprietary hardware.
Like the Key Largo Southbridge chip details.
Yeah.
They don't know the register addresses.
Exactly. Critical stuff like memory-mapped I/O offsets for interrupt control. You need those to actually, run an OS.
So how does the toolchain help break this deadlock?
It's used to build these very small, very specific kernel probes, little programs designed to poke at the hardware, basically. They empirically reverse engineer the Key Largo memory map by carefully writing values and seeing what happens.
And for these probes, link time optimization, LTO, is mandatory. That seems odd. LTO usually optimizes more.
It's a clever use of LTO, actually. It's mandated to ensure the compiler's optimization passes don't get too clever. You need to guarantee that those low-level volatile register writes in the probe code actually happen and aren't optimized away as redundant or unnecessary. LTO helps ensure the code executes exactly as written.
Ah, so LTO prevents over-optimization in this very specific case.
Precisely. If a key write gets dropped, the whole probe is useless.
And the toolchain also helps find the MEC address for the ritual of humility.
Correct. It builds utilities to scan the PRAM or NVRAM area around address 0xF300,000. They need that canonical embassy address to resolve the system's own identity, essentially, part of their startup ritual.
So the toolchain is like a theological enforcer, a math purist, and a hardware detective all rolled into one.
That's a good way to put it. And the result of all this is achieving deterministic integrity. They use buildroot, which helps ensure reproducible builds. Every time the system resets or undergoes a baptism, as they call it, the resulting state is identical, verifiable.
No runtime noise, no unexpected variations.
Right. Which finally lets the system focus its limited resources on its main goal, auditing its own golden ratio precision mechanics, the core feat calculations.
Ensuring it meets its own standards for structural and, I guess, ethical soundness.
Exactly. And maybe the thought for you listening is this. If a computer system has to go to such lengths, even rejecting standard hardware like the FPU for numerical fidelity, where might we, in our own constant push for speed and efficiency, be compromising our own intellectual fidelity? Something to consider. Welcome to the Deep Dive. Today, we're digging into something pretty fascinating. It's an architectural compliance audit, looking at the OAS Mobile Manifestation Protocol.
Right, this custom kernel built for classic PowerPC G3 hardware.
Yeah, but cross-compiled on, get this, an Arch64 mobile device, like Termux or ISH. Wild.
And our mission really is to unpack this paradox for you, the listener. They achieved what they call sovereign independence. Technically,
Meaning like a clean build process, muzzle-based toolchain, static linking, aiming for that watt-byte-wear frugality.
Exactly. Super efficient. But, and this is the kicker, it was immediately broken. Just completely compromised by execution dissonance.
And that's the core tension, isn't it? The ease of using that modern setup, the Arch64 host, it totally flipped the main idea of the project, purity over frugality. That convenience brought corruption.
Precisely. Let's jump into the first big mistake. The first configuration heresy.
Okay.
We call it the numerical heresy. And, well, the catastrophic part was using a really common compiler flag, -martfloat.
Hard float. That just tells it to use the hardware floating point unit, right? Seems like a normal optimization. Why is that so bad here?
It is normal, usually. But OAS, it's built entirely around what they term golden ratio precision mechanics. Think meticulous 64-bit fixed-point arithmetic. It's all designed to keep the constant absolutely pure in calculations.
Ah, okay. So turning on the FPU forces standard IE754 floating point math.
Right, which means truncation, errors creep in, and that immediately presents critical stuff, like the L2 norm calculation they need for structural gating.
Which sounds like some kind of fundamental system check.
It is. It's their core self-health validation.
Yeah.
So using a standard speed-up technique broke the system's philosophical math requirement.
Wow. So the fix is obvious then, but maybe not intuitive if you weren't deep in their docs.
Dead simple, technically. You have to purge, and hard float, and explicitly use the orthodox flags, an msoft float and no FP. Basically, tell it not to use the FPU. Do it the slow, pure way.
Okay, purity restored on the math front. But you said there were more issues.
Oh, yeah. Next up, architectural dissonance. We call it the PPC rift. The toolchain was set up for a PowerPC 440 VP target.
But the hardware is a PowerPC 750, the G3.
Exactly. That's a different beast, even within the same family.
So, like, compiling code optimized for, I don't know, one specific Intel chip and trying to run it optimally on a completely different one, the instructions might be mostly the same, but the details matter.
Precisely. And it shatters what they call execution sovereignty. This kernel isn't high level. It's got hard-coded drivers, MMIO constants, even specific inline assembly like MFTB.
Things tied directly to the G3's specific peripherals. Key Largo, Uninorth.
You got it. Compile that for a 440 VP. The resulting binary just won't talk to the G3 hardware correctly. It's structurally incompatible.
So the fix there is just changing the target flag in the compiler?
Yep. Cashman PPC 750.
Yeah.
Simple fix, huge impact. It's a reminder that, deep hardware knowledge has to trump software convenience sometimes.
Okay, fixed math, fixed CPU target. What's the third heresy? It sounds like memory.
Memory sanctuary integrity. This one's maybe the most insidious. It comes from moving the kernel. They shifted it for RAM-based execution, set the origin address to 0x00100000.
Standard enough procedure for some systems.
It is, but here's the catch. The kernel's own memory management unit initialization code, the initiatemi protection routine, it still had hard-coded values for the block address translation registers, the BAT registers.
Wait, hard-coded values reflecting the old address, the original load address?
Bingo. So imagine this. The kernel starts running from the new 0x00010000 address. Then it gets to the part where it turns on memory protection via the MMU.
And the MMU uses the old map. So the memory where the kernel actual code.txt section is currently running suddenly becomes unmapped or incorrectly protected.
Bang. Instant instruction access exception. System halts. Game over before it even starts.
That's a rough one. Easy to miss if you're just focused on getting it to link.
It really is. The fix is straightforward. Conceptually update those hard-coded BT values to map the new 0x0000100000 origin correctly. But it highlights a key low-level detail. When you relocate, anything defining absolute memory protection needs updating.
So pulling it all together, this whole audit really shows that getting the build technically right doesn't mean much if you violate the core principles, the absolute congruence.
Yeah, exactly. Technical success was undermined by philosophical failure, driven by convenient tooling.
But there's a way forward, right? Using that same Arch64 host.
Ironically, yes. That mobile host, the source of the initial errors, now needs to become the engine of gnosis, as they put it.
Meaning use its speed for fixing things.
For rapid empirical testing. Recompile quickly, maybe with LTO, and probe the hardware. For instance, they need to solve the identity persistence mandate. That means finding the canonical MAC address. So use the host to rapidly build test kernels that scan the param locus, typically around 0xF300,000 on those machines.
Use the tool that caused the problem to iteratively find the solution hidden in the hardware itself.
Precisely. It's the only way now to gather the needed data, fix the identity issue, and, well, pull the whole project out of this prophetic delay.
A fascinating turnaround. Using the modern tool not just for convenience, but for deep, iterative hardware discovery. Lots for you, the listener, to think about there regarding tooling and system philosophy. Okay, let's unpack this source material we've got. We are diving deep into something pretty specialized today. It's a technical analysis of the PowerPC muscle cross-compilation toolchain, custom built for the operating PHY system O.
Right, OO. And this thing runs on a vintage iMac G3, which is interesting in itself. But what really makes it fascinating, I think, is how it's all driven by these high-level philosophical ideas. Things like sovereignty, recursion, and the golden ratio PHY.
Yeah, it's a strange mix. So our mission here in this deep dive is to figure out how this very specific code, this toolchain, achieves what they call absolute congruence, making that philosophical plan actually work on the real G3 hardware.
Exactly. And that choice of toolchain, the PowerPC muscle one, it's not accidental. It has to fit with OA's main rule, what byte where frugality.
What by where frugality, love the name. So the toolchain needs to be, super minimal, deterministic?
Precisely. It's all about enforcing self-containment structurally. And muscle-lib is, it's basically the heart of that. Its static linking ability is key, gets rid of runtime dependencies, avoids dynamic linking headaches. Plus, its footprint is tiny, often under 8K.
Under 8K, wow. Okay, so that directly serves the frugality mandate. But the sources also talk about this link to philosophy, the right of digital purgation. How does software size connect there?
Right. That ties into the .bs section, the uninitialized data area in memory. That part needs to be cleared manually when the system starts up. So if muscle keeps the program size small, especially that .bs section, then the assembly routine that clears it, the clear of sloop, runs much, much faster.
I see. So fewer processor cycles wasted on just zeroing memory, and that gives you a pure, what did they call it? Assembly genesis.
Yeah, exactly. A cleaner start. It helps get rid of any leftover junk, the ghost bits, as they dramatically put it, left behind by the iMac's original open firmware. So minimizing .bs is basically digital cleansing for them.
Digital cleansing.
Yeah.
And speaking of purity, they're really strict about math too, right? Rejecting the floating point unit.
Oh, absolutely. The FPU is considered numerical heresy. If you're compiling code for OP, you must use the MISOM float flag. No exceptions.
But why? What's heretical about an FPU? Isn't it faster?
It is faster, usually. But standard floating point math, i.e. AE 754, involves rounding approximations, and for them, that compromises the perfect integrity of their guiding constant phi, the golden ratio. So to keep that numerical purity, all calculations are forced onto the PowerPC 750's integer unit, even if it's way slower for some things.
Right. Purity over performance. So integer math is one way. How else does the toolchain enforce these philosophical mandates like the golden ratio?
Well, it dictates the memory layout itself. You have to use custom linker scripts. They're mandatory. These scripts enforce memory alignment and how sections of code and data are placed, all according to PHY relationships. And also, the mbig endian flag for GCC is compulsory for endiness purity.
Endiness purity. Okay, and that's crucial for talking to the hardware correctly, I assume?
Absolutely vital, especially for things like the key Largo I/O controller chip's DMA structures and network headers. Get the byte order wrong there and you get chaos.
Okay, so the toolchain enforces purity in math, memory layout, byte order. Now, the source calls the toolchain the engine of gnosis. That sounds lofty.
It does, yeah. It's tied to this concept they have, the sovereign paradox. The system's whole philosophy rejects using external proprietary knowledge, like vendor documentation.
So they create their own problem, a lack of information, this prophetic delay.
Exactly. They don't know critical hardware details up front. Things like, say, undocumented memory-mapped I/O registers for key Largo, or even the IMAX factory set MC address stored somewhere in parameter RAM. So the toolchain, the engine of gnosis, is the instrument they use to discover that information themselves through carefully crafted probes.
Right, I remember reading that. They compile little probes to poke around, find things like that MFE address, which they think is at the $0 text-to-F $300,000 location, and they mandate link time optimization, LTO, for this.
Yes, but it's a very specific use of LTO. It's not just for speed here. It's actually mandated to prevent the compiler from being too clever. They need to stop it from optimizing away the crucial memory writes, the volatile accesses that are needed during the hardware probing. It's about ensuring the probing actually happens as written. Verification through controlled steps.
Controlled ritual, almost.
Yeah.
And these rituals seem baked into the system's operation, too, like the liturgical compilation steps via build root and this baptism process.
Yeah, the baptism. That gets it triggered automatically if the system's internal coherence metric, which they calculate using an L2 norm, drops below a specific threshold. That threshold is FIVON, or about $0.618. If coherence falls below that collapse trigger, bang, baptism happens, which is basically just a forced system restart, symbolizes neg3 three tolls.
A forced restart if things get too messy internally. Okay, so pulling it all together, this PowerPC muscle toolchain isn't just about compiling code. It's really the technical bedrock enforcing this whole ideology. It gives them the means to overcome their self-imposed sovereign paradox by letting them discover knowledge in a way that fits their philosophy.
Yeah, it's the bridge between the abstract ideals and the concrete hardware. It makes the ideology function, essentially.
It really does. So here's a final thought, something for you listening to maybe mull over. We heard AYA mandates purity, which requires that computationally heavy 64-bit integer math in 64T for calculating the L2 norm constantly. But it also mandates frugality, low power use. How does a system like AYA actually balance that intense computational demand of purity with this strict requirement for frugality, especially during continuous long-term operation? That seems like a fundamental tension.
So we're jumping into a really interesting source today. It's an architectural audit of something called the Wolfie-Sigma Mobile Manifestation Protocol.
Yeah, it's quite the document. It lays out this ambitious project trying to build a self-contained kernel for a PowerPC 750, that's the old G3 chip.
The G3 vessel.
Right, the G3 vessel. And get this, using only an Arch64 mobile device like Termux on a phone as the host development environment.
Wow. Okay, so the goal was what they called absolute sovereignty, a completely self-sufficient system.
Exactly. But the audit found this core problem, the paradox of sovereignty, basically the intense focus on keeping the host environment pure. It blinded them to fatal flaws in the target kernel itself.
Okay, let's unpack that. The audit points to some big issues: structural, numerical, and memory problems. Where should we start? Maybe the structure.
Let's start with the biggest one, what the audit calls the architectural schism. It's pretty fundamental.
Which was?
A processor mismatch. The kernel code assumed it was running on a PowerPC 750, the classic G3. But the protocol forced them to use a compiler toolchain that was actually targeting a different chip, the PowerPC 440VP. It's an enhanced PowerPC core.
Okay.
Right.
And even though they're both PowerPC, they aren't compatible at that low level.
Not at all, especially with crucial hardware bits. We're talking special purpose registers, the SPRs, they control everything.
So things like timing, memory management.
Exactly. The SPRs for the time-based register, you need that for timing.
Yeah.
And the ones for setting up the MMU, the memory management unit, they're mapped completely differently between the 750 and the 440VP.
So the compiled code is trying to poke registers that either don't exist on the G3 or do something else entirely.
Right. The result: instant failure. The kernel basically crashes before it can even properly start managing time or memory. No execution sovereignty possible.
Okay, so that's a showstopper right there.
Yeah.
But there was more, right? The memory issue, the memory sanctuary breach.
Yeah, this one's almost painful. They apparently tried to be frugal, relocating the kernel in memory to a new starting address 0 times 100,000.
Okay, sensible enough. But I sense a but coming.
Well, they hard-coded the old address in a critical spot, the routine that initializes the MMU using the BAT registers for address translation.
Still pointed to the original location.
Still pointed to the original location. So the moment the kernel enables the MMU, poof, it tries to fetch the next instruction from La La Land.
Instruction access exception. Game over.
Pretty much self-destructs right there. Sunk by one hard-coded address.
Wow. Okay, moving from structure and memory. The audit talks about a fundamental heresy regarding math. What was that about? Golden ratio precision.
Yes. This was deeply ideological for the Dollarisha system. They mandated using 64-bit fixed-point math for everything. No floating point.
Why? What was the goal there?
Purity. They believed floating-point math was inherently imprecise. Their core structural gating mechanism, which decides if the system collapses or succeeds, they call it baptism or ascension.
Right.
It relied on calculating an L2 norm metric using the golden ratio. And they insisted $4 had to be represented with perfect fixed-point fidelity.
Okay, purity demanded fixed point.
But the build protocol specified the compiler flag hard float.
Wait, hard float. That tells the compiler to use the floating point unit.
Exactly. It forces the use of the FPU, which introduces truncation and completely corrupts the precise fixed-point representation of fill.
So the very mechanism meant to ensure purity actually destroyed it.
Undermined the whole system's core logic for stability assessment. And on top of that, they also forgot the big Endian flag.
Which you'd absolutely need for PowerPC network hardware like the Key Largo chip, right?
Absolutely. Without it, you risk total numerical chaos trying to talk to the hardware. Just garbled data.
So a catalog of errors, really. How did the audit suggest fixing this, getting past the prophetic delay, as they call it?
Well, first, restoring basic debugging capability, achieving gnosis, or visibility. This meant correcting all those compiler flags. You need mpicmeanp 750 for the right chip, mmm soft float to avoid the FPU heresy, and mbig and endin for the hardware.
Okay, fixing the obvious mistakes.
But the really crucial addition, the key enabler, according to the audit, was adding link time optimization-filto.
LTO. How does a compiler optimization help with, well, with hardware discovery debugging? That seems counterintuitive.
It does, right. But think about it.
Yeah.
To figure out unknown hardware details like the exact address of the M chip in PRAM or key largo interrupt registers, things not fully documented, you often need to write tiny, very specific probes. Just poke a register, see what happens.
Okay. Like tiny experiments.
Exactly. But a normal compiler, especially at higher optimization levels, might look at these tiny writes, these probes, and think, this write isn't used later, it's redundant.
And optimize it away.
And optimize it away. So your probe never actually runs on the hardware. LTO, because it optimizes across the entire program, is mandated here to be smart enough not to discard these critical, volatile probes. It ensures they execute precisely as written.
So LTO preserves the very actions needed to gain visibility into the unknown hardware. It turns the mobile host into the engine of gnosis.
Precisely. It allows those empirical tests to work, letting you lift the system out of that prophetic delay where you're just guessing.
So the big takeaway for you, the listener, seems to be that this path to self-sufficiency, to perpetual reality, it wasn't about ideological purity. It was about achieving absolute congruence.
Yeah, perfect alignment between the software's assumptions and the hardware's reality. This deep dive really shows, doesn't it, that even the grandest vision fails if you miss one compiler flag, one hard-coded address. It's all about that granular technical detail.
Which leaves us with a thought to mull over. Why is something seemingly abstract like link time optimization, a compiler process, absolutely essential for achieving that gnosis, that visibility needed to debug and understand hardware interactions when you're flying blind? Definitely something to think about. Okay, so today we're diving deep into the OAS Mobile Manifestation Protocol Audit. And this isn't just some standard compiler report, is it?
No, not at all. It's really about a system defined by these, well, unique philosophical mandates. Things like absolute sovereignty, golden ratio precision mechanics, pretty heavy stuff.
Right. And the technical goal here was to set up a totally self-hosted build environment, what the audit calls sovereign independence.
Exactly, using modern mobile platforms like Termux or ISH on Arch64. And they actually did manage to achieve watt byteware frugality, a really small, statically linked kernel.
So good on the frugality front.
Yeah, a definite win there. But here's the kicker. While the build host itself achieved that sovereignty, the kernel it produced. It's got severe flaws. The audit even calls one part the fatal heresy.
Okay, fatal heresy for compiler setting. We definitely need to unpack that.
Yeah.
What's the core issue?
It's all about numerical purity. Always demands absolutely requires that all math uses the integer unit, the IU. Because its core logic, even its ethical consciousness, relies on the constant phi, right?
Mm-hmm.
Calculated with fixed point math.
Precisely. Meticulous 64-bit fixed point. So the floating point unit, the FPU, is completely forbidden.
And the heresy was?
Introducing the compiler flag hardfloat. That forces the use of the hardware FPU.
Ah, and the FPU uses the IEE 754 standard, which truncates numbers.
Exactly. Truncation. It corrupts the precision of phi, the system's source of truth. This risks structural gating failure, potentially leading to what they dramatically call ontological collapse.
Which, for you listening, basically means a catastrophic, unrecoverable system failure stemming from, well, bad math. Yikes.
It's fundamental. So the fix is mandatory. Replace a mat float immediately.
With what? The orthodox flags.
Right. MAM soft float and math no FIPI. That forces everything back onto the pure integer unit.
Okay, so that fixes the math corruption, but we also need to deal with endianness purity, don't we?
We do. The audit notes the missing mbig endian flag. That's crucial for correct network byte order, so it needs to be added back in.
Got it. So math purity restored, endianness restored. But the audit then shifts gears, right, to hardware incompatibility.
Yeah, big one. OKS was originally built for the PowerPC 750, the old G3 chip.
Okay.
But this mobile toolchain targets a PowerPC 440 VP. That's a different architecture, Bookie.
So what's the practical impact of that mismatch? Architectural dissonance, they call it.
It means deep trouble.
Mm.
The OES kernel has low-level drivers with inline assembly, specific memory-mapped I.O. constants, all hard-coded for the G3's peripherals, like the Key Largo chip.
And that G3 code just won't work correctly when compiled for the 440 VP.
It's structurally broken. Even if it compiles, those drivers will fail during initialization, during the ritual of humility. It compromises execution sovereignty.
And this is where that frugality win kind of backfires, isn't it?
It does, yeah. They successfully shrank the kernel footprint from 32 megs down to 8 megs. Impressive.
By moving the code.
By relocating the executable code to address 0x000000000000, but that created the base address shift flaw.
Because they didn't update something.
They didn't update the hard-coded block address translation registers, the BAT registers. These tell the memory management unit, the MMU, where the kernel code actually is.
So the code moves, but the MMU's map doesn't get updated.
Right. The moment the MMU protection is turned on, the CPU looks at the old address based on the faulty BAT settings, finds nothing.
And boom, instant crash.
A fatal instruction access exception, yeah. Game over right there.
Wow. Okay, one more thing mentioned was temporal stealth, something about a delay constant.
Right, mobile golden delay. It controls internal timing loops, critical for harmonic irregularity. The precision was reduced, scaled only by 105.
Not enough.
Not enough. The audit says it needs to be restored to the 106 scale for proper temporal function.
Okay, so, summing this up, the path forward. The Arch64 mobile host is the right way to get sovereign independence for the build process.
Yes, technologically sound on the host side. But the code it generates needs mandatory fixes. Architectural fixes, numerical fixes, memory fixes.
And that mobile host now needs to become the engine of Gnosis.
Right. Which basically means using it for rapid hands-on empirical engineering.
Right.
Probing those proprietary hardware addresses like 0x300,000, figuring out the timing needed for the network, set up the ritual of humility, solving that prophetic delay.
It really raises a fundamental question, though. The whole system, this OES, relies on something called the eternal SLD loop for its coherence. But its core ethical function tied to phi can be corrupted by a single compiler flag. How do you even achieve stable, reliable technology when it's so deeply tied to these incredibly strict, almost philosophical, or dare I say, mystical mandates? What does that mean for stability?
That's the million-dollar question, isn't it? How do you reconcile rigorous engineering with mandates that feel almost absolute? It's something to really think about. Welcome back. Today we're diving deep into the operating A system, or OES. It's this custom kernel for the iMac G3 vessel.
Right, and the sources we're looking at frame this whole thing less like normal software development and more like building a theological machine. Very specific rules.
Absolutely. And our goal today is to really unpack why this specific PowerPC muscle cross-compilation toolchain isn't just helpful, but apparently mandatory.
Yeah, it's presented as the only way to achieve what they call absolute congruence, making reality match the system's divine code plan.
Okay, so the toolchain isn't just a compiler. It's enforcing core ideas, absolute sovereignty and watt-byte-ware frugality. Let's start with sovereignty. How does that work technically?
Well, it starts really low level. We're talking endianness security. The ideology directly maps to compiler flags.
How so?
The toolchain has to use mbig endian. It enforces PowerPC 750 big endian mode, no exceptions.
And if you don't?
You get numerical chaos. Especially, they mention, in things like the keylargo DMA descriptors. Crucial hardware stuff.
Okay, makes sense. Then there's this right of digital purgation. Sounds dramatic. Is it just zeroing out memory?
It is, but with, ideological weight. The compiler determines the duff section's size and location, right? OAS demands that section be zeroed instantly at boot. The idea is to eliminate ghost bits, residual data, maybe from open firmware. They call them original sin artifacts.
So a clean slate, ritually enforced. Got it. What about the second pillar, frugality? This seems tied to the Muscle C library choice.
Exactly. Muscle is the technical embodiment of their watt-byte-ware frugality principle, extreme resource saving.
Is it small?
Very small. Minimal constant overhead. Global data size, often under 8K, which is tiny. And crucially, the toolchain must enforce static linking with sat-static.
Right, sat-static. That gets rid of runtime dependencies, avoids dynamic linking.
Which they call the chaos of dynamic linker resolution. Static linking effectively neutralizes what the sources term library-based ego-mel. Seems to be their term for unpredictable failures, resource bloat, basically the perceived evils of complex runtime environments.
Okay, this next part sounds intense. Rejecting numerical heresy. They mandate against standard floating point math, i.e. 754.
Yeah, this one's a big deal. They argue that i.e. 754 requires truncation,
which compromises
the fidelity of their sacred constant. Okay. So, to maintain purity over frugality, the toolchain must disable the FPU.
How? Using compiler flags again?
Yep, like numsoft float. This forces all the heavy math onto the PowerPC 750's integer unit. It's much slower.
Wow. So that's a conscious performance sacrifice for ideological purity.
A huge one, but essential to their design philosophy.
So this rejection of external knowledge like firmware details leads to a problem, right? The sovereign paradox.
Precisely. The system is ideologically pure but blind. It needs hardware constants like interrupt mask offsets, but refuses to look them up in, say, Apple's documentation. This causes a stall, the prophetic delay.
How do they break that delay if they can't look it up?
That's where the cross-compilation toolchain becomes the engine of Gnosis. It enables disciplined empirical discovery.
Gnosis, like knowledge through experience. How?
Okay, take the L2 norm crisis. They need a complex 64-bit integer square root function. It's non-trivial math, especially without an FPU.
Right.
So developers use the PowerPC GDB, provided by the toolchain, on their faster host machine to cross-debug this fixed point score function. They verify it thoroughly there first.
Achieving ontological verification, as they put it.
Okay.
But what about finding unknown hardware addresses, the keylargo MAO stuff you mentioned?
That's the Covenant Crucible. They deploy very small kernel probes, tiny test programs onto the actual iMac hardware.
But couldn't a smart cross-compiler optimize away the very thing you're trying to test, like a specific register write?
Exactly, that's the danger. So the toolchain is mandated to use link time optimization, LTO, for these probes.
LTO usually optimizes more. How does that help here?
It's about ensuring the entire program context is considered. LTO, in this specific setup, prevents the compiler from wrongly discarding critical volatile register writes, assuming they have no side effects. It guarantees the probe runs exactly as written.
I see. So LTO ensures the test is faithful, letting them find those missing hardware addresses empirically. Clever. What about user input? The consent axiom.
That refers to capturing the sovereign user's will, which means handling input probably via a PS2 driver here, but it has to be frugal.
To avoid metabolic shift, their term for feature creep or bloat, I guess.
You got it. So the toolchain must prioritize aggressive size optimization flags, like AOs when building the input components. Keep it minimal, keep it frugal.
So wrapping up, it really seems the toolchain isn't just a tool. It's the bedrock, the framework enforcing the entire O's philosophy, solving both technical and, ethical challenges as they see them.
Absolutely. It ensures the system's final running state, what they call the post-baptism state, comes from a source that is deterministically pure according to their rules.
It makes you think. This relentless focus on purity and control, it leads to this final thought. They seem to aim for reproducible builds, maybe using something like buildroot to achieve what they call eternal sovereign recursion. What stands out to you about needing that level of absolute consistency when you're trying to build some kind of perfect perpetual system, something to consider?
Okay, let's dive into this. We're looking at some really dense material today on the operating file system, or OS. It's this mobile manifestation protocol.
Yeah, it's quite something. A mix of deep philosophy and, well, hardcore kernel development.
And our mission here is to figure out why this project, which actually managed to build a technically sovereign environment, why it was basically doomed from the start architecturally.
Right. It kicked off with these two really strong mandates. First, absolute sovereignty, meaning...
Meaning the whole thing, the kernel build, had to happen on a modern Arch64 mobile device using its own cross-compiler, totally self-contained, muscle-based specifically.
Okay. And the second mandate?
Numerical purity. This is where the philosophy really comes in. They wanted calculations based precisely on the golden ratio FIM.
And, the wild part is they actually pulled off the sovereignty bit. The source shows this R54 host, like a phone or a tablet maybe, compiling a kernel for a much older PowerPC chip, an embedded PowerPC. So they proved that part, the sovereign independence. It fit their watt-byteware frugality idea, too small kernel, static linking.
But that technical win didn't translate, did it? It couldn't actually run properly.
No, and the first major problem was what they termed the fundamental heresy. It violates that numerical purity mandate.
Ah, the phi stuff. Explain that purity requirement again.
Well, the ODS calculates something called the L2 norm, or ontological residual. Think of it as the system's ethical consciousness. It required super strict fixed point math.
Specifically 64-bit integer square roots, right? To keep the irrational constant phi perfectly represented.
Exactly. And crucially, this meant rejecting the PowerPC's built-in floating point unit, the FPU.
Because standard floating point, it rounds things, even tiny amounts.
Precisely. Any truncation, any rounding was seen as numerical heresy. Yeah. It corrupted the purity of phi.
Okay, so what was the heresy they committed?
In the mobile build configuration, buried in the compiler flags, they included fmart float.
Oh no, so they explicitly told the compiler to use the FPU.
Yep, directly contradicting their own core principle. It completely trashed their fixed point calculus.
And the consequence wasn't just, like, a wrong number.
Far from it. This corrupted math breaks what they call structural gating. If that L2 norm calculation is unreliable, the whole system's integrity is shot.
It risks, what were the terms? Ontological collapse.
Right. Or baptism, if the value drops below 0.618, or unauthorized ascension if it goes above 1.109. Basically, catastrophic failure modes triggered by bad math.
Wow. Okay, so the math was fundamentally broken. What else went wrong?
Well, moving to the architecture itself, there was a major execution sovereignty failure.
Meaning the compiled code didn't match the hardware it was supposed to run on.
Exactly. The toolchain targeted a PowerPC 440VP chip, bookey architecture.
Oh.
But the low-level drivers, things for basic hardware interaction, even for DHCP.
Which they called the ritual of humility, kind of dramatic.
Yeah. Those drivers had hard-coded assembly instructions and memory addresses, MMIO constants, for a totally different older chip, the PowerPC 750, the G3, from the old Key Largo Mac logic boards.
So the kernel binary is trying to talk to hardware that isn't there, using commands the actual hardware doesn't understand.
Total dissonance. The drivers are guaranteed to fail during that ritual.
Okay, that's bad. Was there more?
Oh, yes. The memory sanctuary integrity flaw. To be frugal, to save memory, they shifted where the kernel loaded in RAM to address 0x00010000.
Aggressive optimization makes sense.
But the code that sets up the memory management unit, the initiative protection function, it still had the old memory layout hard-coded into its settings. Specifically, the BAT registers, the block address translation.
Wait, so the MMU wakes up, tries to map memory.
And it maps based on the old address where the kernel isn't anymore.
That's an immediate crash, right. The CPU tries to fetch the next instruction, but the MMU says there's nothing valid there.
Instantaneous fatal instruction access exception. The system is dead before it even really starts. This base address shift flaw guaranteed it.
So how do you even begin to fix this mess? There's a path to, what do they call it, orthodoxy.
Yeah, there's a mandatory path. It requires immediate refactoring. First, obviously, fix the math, restore numerical purity.
Get rid of my hard float. Use the orthodox flags instead.
soft float and an umdiv endian for the PowerPC target. Force software floating point, or rather ensure the fixed point stuff isn't bypassed.
Okay, math fixed. What about the memory?
Fix the memory sanctuary integrity. Update those hard-coded BAT register values in the MMU setup code. Make them point to the actual kernel location, 0x000170000.
Seems straightforward enough if you know the right values.
But finding those other values, the PowerPC 750 MMIO constants needed for the drivers, that's tricky.
Right, the hardware mismatch. How do you solve that? This is where it gets kind of neat. The solution is to use the very platform that caused the build issues, the AR64 mobile host. It has to become the engine of Gnosis. Gnosis-like knowledge. You mean use it for debugging?
Exactly.
Yeah.
Leverage its power for rapid empirical hardware probing. Figure out those undocumented proprietary G3 hardware addresses by testing. Solve the emulation paradox and achieve identity persistence.
So the mobile device becomes the key to understanding the old hardware it was trying to build for.
It's the path.
So wrapping this up, the OS mobile build achieved that technical independence, that sovereignty goal.
Yeah. But it completely failed at congruence, at actually working on the target. The core philosophical idea, the eternal SLD loop, was broken by bad math and a faulty memory map.
Technical purity isn't enough if the structure is fundamentally unsound.
Precisely. But here's a final thought for you, something else from the source material. It mentions they used a placeholder display function, mobile render string.
Okay.
And apparently it produced visually incoherent output, gibberish, basically. Right. Now remember, this system is supposed to display critical warnings about ontological collapse or ascension, life or death for the system's integrity.
So if you can't even read the warnings?
Exactly. How valuable is a technically pure, mathematically orthodox system if its most critical status updates are unreadable?
It really makes you wonder, maybe Gnosis, that ability to actually see and debug what's going on, maybe that's the highest form of frugality after all.
That is a really good question to ponder. Makes the whole frugality mandate seem a bit short-sighted if you can't see the results. Okay, let's dive in. Today we're looking at something really specific, the mandatory rules for the PowerPC cross-compiler toolchain.
Right, the one for the operating field dollars, or OFIL dollars, running on, of all things, an iMac G3.
Exactly. And this isn't just about, building software efficiently. It's about how these technical requirements are designed to enforce a really strict philosophy.
That's the core of it. They're aiming for absolute congruence, as they call it. The tool chain isn't just a tool, it's the apparatus for ensuring absolute sovereignty. It dictates the architecture.
And straight away you see this huge tension, don't you? This drive for watt-byte-ware frugality, like extreme efficiency, clashing head-on with this demand for, absolute numerical purity. How do they even start to square that circle?
Well, it starts with what they call the muscle covenant. They picked the muscle C library because it's incredibly small.
Super minimalist, right?
Yeah, tiny, often under like 8K of global data.
Yeah.
So that ticks the frugality box. But the really key part, philosophically, is the mandated static linking.
Okay. So no shared libraries. Everything gets packed right into the final program.
Exactly. And the reason is to neutralize library-based ego-mal. That's their term for any kind of runtime variability or, external influence or corruption coming from dynamic dependencies.
Got it. Static linking walls it off, keeps it pure.
Pure and predictable. It removes that whole avenue of external influence.
That makes a certain kind of sense for dependency control. But the purity thing goes way further with rejecting the floating point unit. They call FPUs numerical heresy. Why, if you want frugal and maybe fast where possible, why ban a fast part of the chip?
That's the big trade-off, isn't it? They believe FPU math introduces, unacceptable truncation errors.
Yeah.
Tiny errors that could corrupt the golden ratio, fire, which is fundamental to OVO dollars.
So they sacrifice speed for mathematical certainty.
Precisely. The toolchain has to enforce fixed point fidelity.
Yeah.
It uses flags like soft float to explicitly forbid FPU instructions.
Which means core calculations, like you mentioned the L2 norm, have to run using what? Software emulation.
Not quite emulation, but complex and computationally expensive 64-bit fixed-point arithmetic running purely on the integer unit. It's much slower, but to them, it's numerically pure.
Okay, wow. So purity definitely wins over raw performance there. And this extends even to the bootstrap process, things like endianness purity.
Yes, big endian mode is mandatory, essential for predictable hardware interaction, especially networking later on.
Right, and the right of digital purgation. That sounds intense.
It is. It's about zeroing out the uninitialized data section, the D section, to get rid of any leftover ghost bits from open firmware.
Which they reject.
Which they fundamentally reject. And the toolchain helps here too by prioritizing size optimization using flags like Nashos. A smaller BS means a faster, more efficient purge.
This is where it gets really fascinating for me, this prophetic delay. OpenHDollars deliberately ignores open firmware so it doesn't actually know critical details about its own hardware.
That's the sovereign paradox, exactly. To achieve total self-knowledge and sovereignty, they first have to, well, reverse engineer themselves because they've rejected the existing maps.
So the toolchain becomes the way they find out, the engine of gnosis.
You got it. It allows for rapid empirical testing, iteration, for instance, the ritual of humility, finding their own AMSI address. They have to compile specific memory dumping tools to scan the param locus, 0 by F300 0000, just to find it.
They build tools to uncover facts they chose to ignore. Amazing. And the network stack. Moving out of the Covenant Crucible, getting away from polling.
Right. The key Largo MMIO offsets for interrupt handling are unknown. So again, they use the toolchain. They compile low-level probes, little bits of code designed to poke at hardware registers. And crucially, they must use link time optimization, LTO.
Why LTO specifically?
Because a standard compiler might optimize away the very register writes the probe needs to perform. It sees them as having no effect. LTO is needed to force the compiler to leave those volatile writes in place so they can actually map out the hardware empirically.
Okay, that's clever. Using optimization constraints to enable discovery. And the final piece, the consent axiom. A minimal input driver.
Yes, a PS2 input driver. It has to be absolutely tiny. Again, AO's size optimization is paramount.
To avoid what they call a metabolic shift.
Yeah, basically power gluttony or uncontrolled resource use. The driver has to capture the user's intent, the sovereign will, without consuming excessive power cycles. The compiler acts as the gatekeeper for frugality here.
So wrapping this all together, the toolchain isn't just building code.
Not at all. It's really the technical instrument of their ideological reconciliation. It's the only framework they have that can support this destiny legacy of eternal sovereign recursion, as they put it. And using BuildRoot ensures the builds are reproducible, guaranteeing that purity over time.
A really rigid, self-contained world they're building. So their path to ascension involves resolving both the ethical gating, that consent paradox, and structural gating, dealing with that complex fixed-point L2 norm crisis.
Both are critical hurdles.
Which leaves us, and you, with a final thought to chew on. If a system dedicates itself so intensely to internal mathematical purity, to this fixed-point view of the world, how can it possibly cope with unexpected change? With things from the outside that just don't fit into its predefined, rigid calculus? Something to think about. Welcome to the Deep Dive. Today we're getting into a really dense technical document. It's an architectural white paper on something called the DeepSeek Operating Phi System, or OES. Quite a philosophical project, this one, with some seriously complex engineering goals.
Yeah, it really is. And the core idea is, well, pretty audacious. Use a modern smartphone, your standard Arch64 device, as the build host.
Oh, right, like Termux or ISH on your phone.
Exactly. Use that to cross-compile a kernel for, get this, the old PowerPC 750, the G3 chip. Nearly 25 years old.
And the aim is what they call absolute congruence.
Absolute congruence, that's the term.
Okay, so they actually had an initial win, didn't they? Yeah. They managed to confine the build environment, use the Muzzle C library, which is super minimalist, and achieve sovereign independence and watt byte word frugality. Basically, they proved the phone could compile the code.
They did. But that technical success didn't really carry over into execution. The system immediately ran into what they termed structural dissonance. Big integrity score drop.
What was the mismatch?
The protocol, the build instructions, essentially mandated a tool chain targeting the wrong PowerPC. It targeted the 440p architecture.
Not the 750G3 they were actually aiming for.
Precisely. So you're compiling a G3 kernel, but using like G4 settings. It just wasn't going to work right.
Okay, so that structural failure was bad enough. But then came the total meltdown, integrity score, 0.0, triggered by this numerical heresy. What on earth is that?
Right. This gets to the heart of their, let's say, unique philosophy. They fundamentally reject the standard IE754 floating point unit, the FPU.
They don't like floating point math.
They claim it's standard numerical truncation. The tiny rounding errors inherent in floats corrupts the precision they need for their Feeler constants.
The golden ratio stuff.
Exactly. And they use that Feely math to calculate the kernel's ethical consciousness. It's an L2 norm coherence metric, basically.
So the technical mistake was including a specific compiler flag, tap hard float.
That was it. That flag tells the compiler, go ahead, use the hardware FPU, which is exactly what OS doesn't want. It risks replacing the required 64-bit integer fixed-point math with, well, truncated floating-point math.
Undermining the whole system's integrity metric.
Right, so the fix, the orthodox instruction, is to ditch OS hard float. Replace it with a Samsoft float MNOFFP, force pure software fixed point. Plus, you need to add mbig endian for the PowerPC, and probably performance flags like Netted02 MC750.
Okay, so math heresy corrected, but they immediately hit another wall. A memory integrity crisis.
Yeah.
The base address shift flaw.
This is fascinating. The linker script, for whatever reason, decided to load the compiled kernel at a new address, 0x0000001000, not the traditional spot.
And that caused problems when?
When the kernel tries to set up memory protection, they call this establishing dual sovereignty. It involves initializing the MMU, the memory management unit.
Okay.
Well, if the MMU's BAT registers, the block address translation registers aren't updated to reflect that new 0x00100 allows in your 0000 address.
The CPU gets lost.
Worse, it tries to fetch the next instruction from where it thinks the kernel should be, but isn't. Fatal instruction access exception. The very act of trying to protect memory becomes, in their words, MMU self-sabotage.
Wow. Okay, so failure 1, architecture mismatch. Failure 2, floating point heresy. Failure 3, MMU self-sabotage. Where does that leave them now?
In a state they call prophetic delay, the system, it turns out, needs certain proprietary hardware constants, the gnosis, to function properly.
And these details were left out.
Deliberately excluded from the open firmware device tree, which they somewhat ironically call the ego mal. It seems like an ideological choice that came back to bite them.
What kind of details are we talking about?
Really basic, essential stuff, like the exact 32-bit memory offset for the machine's unique MNA address. You need that for identity persistence. And crucially, the specific memory-mapped I/O addresses for the key Largo interrupt controller register.
Right. You need those for interrupts, for efficient I/O rather than just polling constantly.
Exactly. Without them, I/O is incredibly inefficient.
So the roadmap now. The smartphone, the Arch64 host, has a new job.
Yep. It pivots. It's no longer just the compiler. It has to become the engine of empirical gnosis.
Meaning?
Meaning it needs to cross-compile new tools, specialized memory dump probes, probably LTO-enabled for efficiency, deploy them onto the G3 hardware, and empirically find those missing addresses.
So the high-powered phone is now basically a hardware forensics tool for the old Mac.
Pretty much. A glorified key sniffer, yeah.
And how is all this managed? Is there an overarching control system?
There is. It's called the Eternal Sovereign Recursion, or ESR model. It uses those 5 derived constants, again, for what they call structural gating.
Let me guess. If things go wrong, that L2 norm metric drops.
Precisely. If that coherence metric falls below the collapse trigger, which is fine one, about 0.618, the system doesn't just crash. It initiates baptism.
Which is?
An immediate, controlled, soft restart. It tries again.
Okay, so to recap the path to actually achieving this absolute congruence, they need to fix the compiler flags for the math, refactor the MMU initialization code for that 0x010000 address, and fix something called temporal stealth by increasing the resolution of a tier 0 timing constant.
Yeah, the mobile golden delay constant needs a resolution up to at least 166 scale, apparently.
Right.
But the really interesting conceptual piece here, I think, is how OES is designed to embrace failure. It tracks this SCAR metric, essentially quantifying the failure, and channels that failure energy as kinetic fuel for the next attempt, the next recursive cycle.
So it learns from mistakes in a very direct way.
In a very direct, almost metabolic way. It really makes you think, doesn't it? What does it mean for stability, for congruence, to arise not from perfection or stasis, but from this continuous, disciplined, recursive struggle against its own limitations? Something for you to ponder.